The objective of this lesson is to determine the value of a ratio and calculate the unit rate of a given ratio. This lesson involves determining equivalent ratios by combining, iterating, or partitioning. Let's look at a ratio problem that involves mixing paint. A mixture of paint is made by combining 6 cans of blue paint for every 3 cans of green paint. How many cans of green paint are needed when 8 cans of blue paint are used? One way to find the number of green paint cans is to look at the relationship of the 6 cans of blue paint to the 3 cans of green. What do we notice about the number of blue and green cans of paint? The number of 3 green cans is equal to half of the number of 6 blue cans. 6 divided by 2 is 3. Now look at the 8 cans of blue paint. 8 divided by 2, or half of 8, is 4, so we can determine that we will need 4 cans of green paint. Another way to find the number of green cans of paint is to find the unit rate by dividing the first term of a ratio by the second term. For example, the ratio 6 to 3, 6 is divided by 3. This describes the quantity of blue paint for every 1 can of green paint. If we use the simplest form of this ratio, 2 to 1, there are 2 cans of blue paint for every 1 can of green paint. What if we wanted to find out how many cans of green paint for every 1 can of blue paint? The ratio order is now switched. Rewrite the ratio as the number of cans of green paint to the number of cans of blue paint. Now we have 1/2 green paint to 1 can of blue paint. It is important to recognize which rate is most useful for solving a problem. Let's continue with this problem. How many cans of green paint would be needed if 7 cans of blue paint were used? The arrow shows the relationship between the top row and the bottom row of the table, or the number of cans of blue paint to the number of green cans of paint. By using the unit rate 1/2 can of green paint per every can of blue paint, we can multiply 7 cans of blue paint by 1/2 and determine that there will be 3.5 cans of green paint for every 7 cans of blue paint. Once the unit rate has been determined, this method can be used to find larger ratios when dealing with small and large numbers. Let's try one more problem. A faucet drips 6 ounces in 8 minutes. How many ounces will have dripped after 26 minutes? Let's model this using the double number lines and ratio tables. We know that we need ounces per minute, so let's draw a double number line with the top line representing ounces and the bottom number line representing the minutes. We'll mark a 0 at the beginning of each line. Let's go ahead and mark the 6 ounces in 8 minutes. To find the unit rate, we can divide the 6 ounces in half and get 3 ounces, and divide 8 minutes in half to get 4 minutes. If we do that again, we get 3 divided by 2 is 1 1/2 ounces, and 4 minutes divided by 2 is 2 minutes. Let's divide by half one more time. 1 1/2 divided by 2 is 3/4 ounces, and 2 minutes divided by 2 is 1 minute. Our unit rate is 3/4 ounces per minute. Now we can multiply 3/4 by 26 minutes. 19 1/2 ounces. To solve this problem with a ratio table, we learned earlier that the unit rate could be determined by writing the ratio as a fraction over 1. The faucet drips 6/8, or an equivalent fraction is 3/4 of an ounce per minute. If we multiply both by 26, we get that the faucet drips 19 1/2 ounces every 26 minutes. The objective of this lesson was to determine the value of a ratio and calculate the ratio of a given rate. We met this objective by using tables and double number lines and dividing the first term of a ratio by the second term of a ratio.